Emotions. Let's go.
I think we can start. So, again, I'm not like a teacher or something like that. I don't pretend to know everything about all this. I just give my vision of the things, and yeah, if anything goes, if I say anything wrong or things you know better, of course, please share and send that to the community. I will be eager to learn. I just give like my vision of things and what I've discovered about this. I want to thank the Ollama Discord channel for giving me this room to express it, and the Unsloth guy for their terrible work and the assistance to make it work on Ollama and their support that will be releasing right now. So again, thank you guys, and let's go. So, an emotional llama, we want to create a model that is basically capable of centering emotions in text of users. And this is one particular topic, but I just want to streamline or explain the entire process of making fine tunes and why you would make fine tunes for it, right? So let's go with this. First of all, I just want to state where we stand in the complexity of making models and so on. And therefore, I created that little graph um, from the low complexity and low cost till the high complex and high cost things. So, how do you get your model from zero to hero? And what are the steps? And what can you do at each of these steps to improve your model's performance overall? So, in the first stage, we have the lowest level. So things you can do without even starting to code, or things you can do just out of the blue without requiring much more, neither knowledge, neither programming or whatever. So first of all, yeah, model selection. Choose a good model. The parameter size will be important if you're doing some coding task. Choose a code model. If you're doing some specific task like medical or juridical stuff, you have models that are tailored to that. If you're on the other side of the world and you have languages to cope with, then language tailored solutions will be probably most adapted to you. There are always three dots at the end because that's not all. I didn't want to be totally exhaustive about the methods that can be applied, but just give you hints and tips about it. So once you've selected the good model, that has its limit. There's not much more that you can do than that. So at that point, the next step would be to do some prompt engineering. And there also you got the limits, but you can start to do some few shots prompting. You can do context learning, so give a lot of context information into your prompt so that the LLM learns about your specific usage during the prompt. You can apply things like chain of thoughts, and then you can go even deeper with DSPY to really fine tune your prompts and so on. But again, that has its limits. You cannot put everything into um, finally the prompt itself. The notes and this one will be published part of my cookbook and also in the notebooks. I will push all this on GitHub later on. So yeah, it will be all be available. Um, what is next? Once you've exhausted all these like low level steps, then the next step would be to go for more contextual information. So you can add chat history to make sure that the bot reminds what happened like 3 messages ago. You can add a lot of other forms of history, memory, sorry. You can then also add like intent detection to know like what is the users intending to do, and then you can adapt your prompts or put other information into the context and so on. So that's like a little bit more programming, but still on the easy side, just to guide your model on the good path of what you want to do. Later on, you can then use agentic frameworks, and we did like an entire video presentation about Crew AI. But this is then about using chains and having agents like interact with each other or reflect on their own. That's what React is. It's like reason and act, so they can see their own outputs and see whatever they would adjust or do something else. You can have a tree of thoughts, so that's like also multi-step evaluation of like first think about a couple of things, then go evaluate each of those pathways, and finally make an answer to the user. So these are all bit more complex items you can put in place. But again, it has its limits. I mean, you don't have any external information. So at which point can you make sure that your model is right, truthful, doesn't hallucinate, knows about the very latest information, is not limited to only his training context? So then we go to function calling. Function calling allows a model to start to invoke stuff. It can invoke external sources like Wikipedia, do web searches, APIs, executing code or whatnot, right? One of the next things is the embeddings. Sorry, the rags. So in rags, you would use embeddings, vector stores, query decomposition. So you take a question of the user, you split that up into multiple questions, and you get multiple answers from the model. And then the last one will regroup all that and formulate a final answer. um, Going deeper on that, you can have knowledge graphs, and I could have like a 2 hour show just on ontologies and graphs and so on and so on. But that's basically how you would ground your model to have more knowledge and make your model like a domain matter expert on something, right? So next step then, once you have exhausted all these, and I can tell you that this is already a lot of possibilities to improvement, but your model will still not be like 100% right, or will not give consistently the good answers 9 out of 10 or 10 out of 10, right? So the next step is then to create fine tunes. So we're gonna see today, this is just to a little bit put in place where we are today. Today we are in this part. So we have done another talk about this, and just to make sure you understand that there are a lot of other solutions before reaching this point. This point is when you really are already in like the ninja tricks to get your model from a 7 out of 10 to an 8 or 9 good answers out of 10, right? So we will see the training with Unsloth. There are other solutions also too. And once the fine tuning is done, the next step would be to go to reinforcement learning. And therefore, you will need reward functions, human feedback, direct preference optimization, and whatnot. I mean, there's a lot of things you can do at that stage. Um, so that's a little bit the path from zero to hero. And this is an iterative path. So that's not gonna happen in one shot. You basically will start with a couple of things and go on, go on, go on, go on, repeat, rinse and repeat, test another model, evaluate different things. So I think one of the most important things there is to put in some measurements, put in some metrics, start to be able to evaluate your micro steps, the one after the other, and make sure you're going into the right direction and handle cope with problems as soon as you can, right? So, a couple of links there about there's Hugging Face LLM leaderboard. So that's for here in the step one where you need to choose your models. Hugging Face is making like a good leaderboard when you can see all the models, their answers on multiple benchmarks, and so on and so on. So that can help you to select a good model. The Ollama library, of course, when you're looking for a model, and let's say you're looking for code models, well, just type code, and you will have a lot of code-alike models, and start to try them out with different parameter sizes, and so on and so on. DSPY was presented like yesterday at the AI Makerspace. They have a lot of other very interesting videos, which you guys should absolutely check out. But DSPY is how to code-based have a code-based approach to fine tune your model, your sorry, your prompt. I'm trying sometimes to read a little bit of the comments in there. So yeah, the notes will be shared. I just wanted to keep them like private up to the end of the show so that everyone's attention is here, and then I will share all this, of course. Um, there are a couple of LangChain memory tactics and classes to use. I recommend you looking at that. There is the Crew AI. Crew AI, and one of the videos is on my YouTube channel, is what we've done last time, also 2 hours presentation about how to use Crew AI. when it comes to function calling and so on, LangChain has like a plethora of tools and utilities you can use to do. I mean, the limits are very, very broad of what you all can integrate as tools and get information from. Um, then, if you're starting to do some rags, I would recommend deeply the rag from scratch from LangChain. This is like a playlist of videos and also notebooks going from a rag for zero to a rag of a hero. So you got different techniques in there and so on and so on. Really recommend that playlist as much as I can. Then again, in the same topic of the rags, there is like the embeddings. So there is also an embeddings a leaderboard being done by Hugging Face where you can check the embedding dimensions, the size of it, and whenever it's good at clustering or pairwise classification, retrieval, and so on and so on. So choosing your right embeddings will be like a little bit of a science in the same thing as choosing the right vector stores and so on and so on. I think I make it all. Yeah, Unsloth, of course. We're gonna discuss about Unsloth, and they will present it also. Um, so yeah, I think this is a good presentation of what the process can be to go from zero to hero for your LLM. I don't know if there are already like questions around or something someone wanna agree, disagree on what I've just explained.
Um, I think you're doing good. I sent your cookbook and your YouTube in the chat so that people can find those. But yeah, I'm following along pretty well here.
Abs-
I
mhm,
appreciate all this so far. Yeah.
Great,
Absolutely
great.
fine as well.
So, as the diagram states, this improvement will improve on quality, but also on the complexity and cost. The more you go on the right side of the chart, the more you things you will handle. If you're talking about agentic frameworks and tools, that means you will need more integrations. If you're paying an API like OpenAI or whatever, that means more tokens. If it means more tokens, even though you run that locally, that means more GPU power, more latency, and so on. So all these have a cost, not, I mean, and when I say cost, it might not be directly related to dollars, but latency on your calls,
Mm,
complexity to handle it, and so on and so on. So there is a complexity, like it is going exponentially high. And for who is like familiar with service level agreements and those kind of things, when you got 99.9 of availability, that has some price. And then you want to have 99.99, that costs like double as much. And 99.999 will cost even as double as that. So the more you're going to try to reach the perfect element, the more it's going to cost you and the more difficult it's going to be to handle and take care of that, right? So one of the important things to do, and I just explained that, is like this is an iterative process, multiple elements into the chain. So at some point, you will need to, yeah, sorry, that graph was like an easy thing, but I just wanted to demonstrate the point of, yeah, the more you go to the right side of the chart, the more it's gonna cost and handle, right? Um, so one of the important things is to start to have evaluation metrics to somewhere being able to measure the performance of your model. So there are a lot of evaluation metrics, and I have a part of my cookbook which is dedicated to that. So I recommend you guys to go look on that if you want to get more about the evaluation metrics. But you got things like perplexity, which basically assesses the model's certainty about the next token. You got evaluations like Rouge and Bleu, which are used for summarization or translation tasks. I mean, yeah, a lot of those different matrices can be used, and depending on your problem or what you try to achieve with your model, you might be using a subset of these metrics, right? I'm gonna create a very simple evaluator here in using LangChain. And so this is a little piece of the Python code that I'm gonna use an evaluator LLM and a student LLM. In my case, I'm gonna use Ollama for both, but and Llama 3 for both. just to give you an example of what the evaluator is, it's like this is the question, this is the real answer, and this is what my LLM would be responding. And so if I ask to the evaluator to evaluate this, then the result is that the student's answer was the capital of France is Paris, which is the true answer is Paris. So grade correct, right? This evaluator allows us to, because it's kind of difficult to have the exact answer. Your model will answer something like, yes, sure, the capital of Paris. So it's not an exact string. It's more, you need, in this case, I use an LLM to evaluate whatever the response sounds correct, even though it's not in the exact same words as what was intended, right? So one of the important things is to verify your evaluator. In the case of the sentiment analysis, I had a problem because some of the sentences were, how would I say, grammatically not correct or insulting or those kind of things. And if you then ask a model that is censored to give you advice about a sentence, he might just say, well, I'm not allowed because this is harmful content, right? So you have to check that your evaluator does what it has to do. So basically, normally you have only correct and incorrect. But would you have something like, hey, there is an error, I cannot do that because I'm in AI, I should not do harmful things? Then this will count down into the unknowns. So I've now just changed this answer by saying that the capital of France is Brussels. And yeah, I got an incorrect answer. So that's kind of great. Um, Once you have that, make a baseline. So test it out. Score on a part of your data set, and we will see about train, test, and other ways to make your data set. But basically, make your baseline. What um, at least they should be more like something should look at, because normally your model should only answer correct or incorrect. So the question was, should denials be incorrect? Um, I mean, denial is probably a problem in your evaluator that you should correct. So you need to pay attention to that unknown. Normally, they should be zero because your evaluator is only supposed to answer correct or incorrect. So I just wanted to make it a point that I cannot just make an if and an else. I needed to make an if to make sure that it was either one or the other and pay attention to the rest. So put a print in there at some points to see what was happening, basically.
Is this
So
different from like a ranking system where you'd have it rank based on scores from 0 to 10 of how leveled
you can
something
ask
is?
it a score. I mean, this one is just like true false as an answer. But in my case, I just wanted to use something that would count um, correct and incorrect answers. If you ask a score, then you're gonna start to have like an average, a weighted average. You're gonna have numbers that are more subjective than
Yeah,
objective, right?
it's really trying to like how dope is this on a scale of 0 to 10? Like, well, what even is dope?
Yeah, and I mean, then you get numbers which will be different depending on the LLM you're using and so on and so on. So I think like correct and incorrect is like a binary answer, right? That should
Mm.
be like straightforward. If you ask, give it a score between 0 and 10 on how correct this answer is, yeah, that's gonna be a kind of difficult things to finally evaluate if your model did better or not better. That's more like a subjective answer you will obtain from
Mm-hmm.
your
Mm.
LLM, right?
Yeah, yeah.
Interesting.
So create a baseline, and I will show how to create a baseline. But at the end, this is it. We now have a metric, we have a model, and we can start. If we take back our chart, we can start changing the models, making better prompts, and so on, and see how the metric evolve in time, right? Then you could do all this, but let's say we have that metric in place, and now we're gonna jump to a fine
Tim
tuning
Tim
directly.
Tim has a question in the chat for you about that code there.
What
He's
if it says I
you
don't know? It also go as unknown. Yes, because we just supposed to have correct or incorrect, so that would also go to the unknown. But as again, normally your question set should be the prompts for the evaluator are kind of easy normally, and they inform the model that it should answer correct or incorrect. The the fact that he answers something else that does not contain incorrect or correct as word definitely will show that there is a problem with your evaluator LLM. Either because, as said, you have the censoring stuff limits coming in, or so. But so these are things that normally, before even starting to make your baseline, you should just make sure that this number remains to zero. If it's something else than zero, then you have a problem because normally the prompts and everything is clear that there should be only a true or a false answer. Right. So um, we're gonna use the emotions dataset, the Go emotions dataset on Hugging Face, which is a dataset produced by Google. Um, this one contains a lot of data that's comes from uh, Reddit channels, and it contains 200,000 messages, something like that. I mean, still everything clear for everybody else? No other questions around currently? We're fine.
We're chilling.
Yeah. Looks like we're good here on the Slido. No one's got questions. We're all good.
I'll send the
Great.
Slido again in case people don't have the Slido. You can send like weird questions to the Slido and you can upvote them together. And if you guys have like really crazy stuff, I don't know, you can vote.
Right. So now a little bit of data science because there is no better thing than I mean this quote is like always and ever real, like garbage in, garbage out. If you don't know what you're training on, then don't expect to have good results, right? So there is a need to go check to the data and go check what the data is all about, right? So I made a notebook about that, and we will get an eye on this.
And this code that you're showing right now will be in the GitHub.
Yep, yep. It will be shared. No problem. Yeah, I spent a bit of time, not too much, to generate like nice graphics. Yeah, that's the dataset, Daniel. You're right. And also, I'm pushing my refined version and the fine-tuned version, so you can directly use them in the Google Colab with the prompts prepared and so on. We will do some data augmentation and this kind of thing. So I will explain it along, but you will also get my emotions data set on my Hugging Face account, so you can directly test it out without going all through all this, right? But so a little bit of data science. I'm not like a very big fan of data science, but it is a need. Otherwise, you will have that garbage in, garbage out issue that I just talked about. So very easily, we will load the datasets from Hugging Face in this case. I'm gonna save it to a local file in the end to reuse it as much. And we see that we have 200,000 and text, so pieces of comments coming from Reddit channels, right? So let's take an eye on our text column, which is basically where the comments are stored. And then just by using the describe function, we already have a description about this. So what does that say? That we have 211,000 messages that on average, there are like 70 chars long, that the smallest one is 2 chars long, that the biggest one is 700 chars long. So do here is to have a little bit of a step back to just say, okay, what I'm evaluating emotions. What can 2 characters convey as an emotion? Well, probably not that much, right? And on the other side, what can 703 characters be meaningful for emotions? That's probably way too long, or that would be like tagged with 10 or 15 emotions. So having an average around the 70 and so on sounds like a good thing, and we probably want to keep out, get out of the garbage from the other ones. So I will now plot the distribution, and fancy charts are always nice, right? So um, this doesn't tell us, except the mean and the average, what the general length of a message is. Well, this does. Like from 100 to 200 messages is like the most you have. And then you have like those couple of 700 that pull out the graph to total. But this is basically the distribution in this site. So if we just like remove everything which is below 3, or sorry, let's first display what is below 3. Okay, and like the smiley figure. That's probably not interesting. And normally said, I would just even remove everything which is under 10 characters. But then if we take a look at this, well, we are doing an emotion classifier. So these messages, even though they are less than 10 chars long, they make sense in emotion classification. So I will basically keep these, right? You can, of course, do some fine-grained, some like this one probably is not interesting, and so on. So up to you to go into the depth of analyzing every single of the 200,000 messages. I'm more like taking big lines and cutting off the grease in big slices. So the 2 characters long doesn't represent that much for me. So I'm probably gonna remove those. The 3 characters long, sorry. I'm gonna probably remove those. And on the other side, I'm fairly interested to know what's above the 200. So let's see this. And it looks like someone has like put some ASCII art into it, which I mean, it's not that I don't like ASCII art, but what can that do for my emotion detection? Probably not that much.
And these are
And on the
from
other side,
Reddit, right? This is a Reddit
yeah,
data set.
yeah, it was curated. Apparently not that good, but it was collected from Reddit and curated from there. So I mean, this probably also doesn't interest me. Way too much garbage. This is like scores from baseball matches or whatever. Doesn't interest me neither. So, for these 1, 2, 3, 4, 5, 6, 7 records that we have that are above the 200, I can throw them away. I mean, I will not lose that much of sensible information. So I will now take my dataset and only take the above 3 and below 200 messages, below or equal to 100 messages. So once we have stripped that out, our graph is now like a bit more compressed and we have a much better view on what's happening in there, right? So let's do that describe again. Because one of the interesting thing is that there are 200,000 messages, but apparently there are only around 60,000 unique messages. The rest is duplicates. So what about those duplicates and how do we come there? But basically, if you analyze the data set, it was a couple of 60,000 messages that were rated by a lot of people. So different raters have probably also given different sentiments to the same sentence. And if I use this as is as a training set, well, my training metrics will never come good because we have conflicting definitions on the same thing and so on and so on. So that's probably not a good thing. So I will now like remove the duplicates, and to remove the duplicates, what do I do with the emotions? So the dataset is as follows, is that you have a column for each and every emotion, and then normally a 1 or a 0 in each category. So what I'm now going to do is group them by text, and I will make the sum of all the emotions in that column. So for this particular message, there were 3 ratings as curiosity. In this, there was 1 for approval, 2 for annoyance, 1 for anger, and so on. So we will now sum up all the votes from the different persons so that we get, I would say, a majority vote, or at least we count up all the votes, and then we will apply another technique to select the ones that are interesting enough for us. Again, I'm doing this with like a quick sense. You could go drill down and check every message. I'm now just applying global rules, which I found interesting in this case to do, right? I don't say that this is the very unique science to do it, right? So we will now strip down our data set, and then we have something like this coming up. So for each and every sentiment now, or emotion, sorry, we have the number of votes given by different raters, but now the number of columns we have in total in our data set is the number of messages we have as unique messages. So I've said that there were different conflicting votes and so on and so on. So now the interesting part is to see if there is a correlation between them. And from the outside, we can see that there are some patterns here in colors that you can see appearing between some emotions. And one of the interesting things is like these four, which make that little square here, and says that basically there is often a correlation in the votes between disapproval, disappointment, disgust, and embarrassment, which is like kind of the same emotions, or at least it's in the same direction of negativity, right? The things I don't like is more that there is correlation with neutral, which means that a lot of messages are marked neutral and with emotions. And I mean, that sounds for me like a little bit in logic, right? So that's something I want to clear out. For the rest, it's kind of okay. I mean, here again, we have those negative feelings, and they are also associated with anger and annoyance. So most of the patterns make a little bit of sense. There is no big discrepancy or astonish. I mean, not something I find really weird about it. Just that last line is for me not that good to show. So let's go on. Yeah, I didn't execute the preview cell, so let me do this again. Demo effect, of course. So that we've done. What did I do? Keyboard insert, that's a double click I did. Yeah, that was a double click, my bad. Okay, so the heat map coming over again. So now I have this matrix which gives me the counts of every message that is also associated to another emotion, right? So this is my problem here, is that there are a lot of neutral messages being also associated with another emotion, which is something I really don't like. Something else that we can see is, if we look at the diagonals here, is that there are some emotions that are really unbalanced, and we will talk about the balancing of the emotions a little bit later, but we already can see that there are like big categories with 36,000 messages having admiration being set, where some others are like represented with like less than 1,000 examples, right? So that's probably not a good thing to have such an imbalance in the dataset. So what I will be doing now is remove everything. Well, again, that's one of my decision with the wet finger, but I consider that everything that has something else than neutral as emotion should not be neutral, and the other way around. So everything that has no other emotions can be set as neutral. Everything that has neutral and something else will lose his neutral statement. Okay, so let's take all the columns except the neutral one. And now let's make some counts about it. Let's remove the conflicting neutral. That's gonna take a bit of
Yeah, I
time.
mean, just to
So
re-explain that, you can't be like neutral admirable. Like you're gonna be neutral if you're neutral. That's the idea here, is that you don't want to be
yeah,
neutral and some other emotion. That's just kind of a weird piece of data.
yes. And probably you may want to do something like a coarse grained, fine grained thing where you say that annoyance and sadness are negative emotions and that they normally cannot be also associated with positive emotions in the same message and so on and so on. So again, I'm not saying that my data science part here is absolutely perfect. I just try to cut out the grease out of that 200,000 messages, which are apparently only 60,000 that are unique, and then to handle some senseful kind of emotions into the thing. Because otherwise, you try to train garbage, you're gonna get garbage out, right? So let's get back to this chart now. And now we see that we've properly cleaned out all these neutral with something else, and we still have 83,000 messages which are just neutral with neutral and nothing else, right? Don't know if that makes all sense for everyone, and if any questions or some things arise, right?
We
And
haven't
I
had
think you
any
explained
questions
the
yet.
one quite clearly. Hmm?
In chat, at least we haven't had any questions in chat yet.
I love the
Yeah.
comment, man.
But
Well, now it looks like a real
I
heat map, Daniel, right? Now it looks
yeah.
like something that makes sense.
Yeah.
When
Again, you
you
have to take a step back. You have to take a step back sometimes when doing those kind of things. And I know data science is not that some funny thing, but it's necessarily it's necessary to do it and to really step back and see. Well, like I said, simple questions like what can a message of more than 700 chars convey as emotions? How can that be interesting? Not at all. How can a message be lower than 3 chars and convey some emotions? Okay is of course like approval, but is that really something sensible to put in there, right? So yeah, um, now we have removed that all. Again, one of the things is that there are probably for each and every message more than one emotion, even two, three, or maybe four, five, six, seven, eight. That might be not interesting at all, neither, right? So what I will do now, and again, it's only my own rule, and you can put some higher numbers here, but it's basically for each row, I will only keep a set of 3 labels. The top 3 labels. We've seen a little bit higher here. Now we had some votes. So we have a couple of rankers given the same advice. So I consider that if there were 2 or 3 persons, considering that this was this kind of emotion, that it was anger and annoyance, they are probably more right than the only guy that said that this was approval. So I'm going to take now the top 3 of the most voted emotions into each message to consider that as being the valid emotions. So that's yet again another piece of code I'll execute. And what we will do is then put all the other emotions on that line to 0 and put the valid emotions to 1. So that now basically for each row I will have only at max 3 times a 1 and all zeros. Take a little bit of time.
Well, definitely.
Yeah. Well, there are a couple of rows into the dataset, and he needs to always rank and organize. And my code is probably not the most efficient in the Panda-wise way, but I mean, it works. And shouldn't be long anymore. Give it a couple of seconds. Like we need a roll drum. Like.
Yeah.
I don't know. We
Hello.
can't do the things that you can do in the other channel. You know, the like the clapping.
The soundbar. Yeah, that might be not a bad idea, by the way. But
I
that's good.
don't I don't
So
think it's in here. I think it's just not
no. But that's fine. That's fine. I mean, so basically now for each and every message, I just made sure that we only have 3 times a 1 maximum. It could be lower than that, because at some point, if you don't have at least one vote and you just take I think the n largest 3, right? But here I also check that these are above 0 because the largest 3, even though there is none, you would basically take the 3 first of the 3 first. So you would have a lot of things being categorized as anger, no, sorry, admiration, amusement, and anger, because even though you take the largest one and there are no votes at all, these are the 3 first in the series. So I check also that there is at least one vote for them. And so that makes that now I will have at maximum 3 times 1, maybe less than that. If everyone had an agreement on this is surprise, then I will only have a 1 in surprise and in nothing else of the rows, right? So now we have already like a more interesting data set, right? Now we have cleared out everything that conveys more than 3 emotions that were not consensually voted by multiple raters to being like that. We have removed the duplicates, 2 large messages, 2 small messages, and so on. That's already a much more cleaned out version of our data set. So now the next step, we need to stratify the dataset. Stratify means that I will split up my dataset in train and test. Something I will train on, something that I will use to test the data on. So what we will do with stratification is that this is a combination of number of labels. In this case, it's the neutral ones, right? So I have 4,235 labels being noted as neutral. I want to split that into test and train data sets. So that's kind of an easy part because I can take 10%, 20%, 30% of this and put them into two categories, right? So now, one of the more difficult things is to stratify elements of which I only have one occurrence. So the combination of this very part of sentiments and emotions, sorry, don't ask me which one they are, but basically they appear only once into my entire data set. So all these with a one are things that I can either put in train, either put in test, but not in both or not split into both. So for me, these are elements I will remove. I will only keep the ones that I can split up into the two categories. So now we're gonna take everything which is in, what did I do? That sounds like the double same thing. Demo effect, what did I do? Sometimes you just need to re-click that. Don't worry, it's gonna be right. Okay, so
Promise us with you there in spirit, bro.
but I mean, I might be a little bit nervous, so I might sometimes double click on the play button and that like do the keyword cancel in the same thing. But anyway, so
You're on fire. Keep going, bud.
we have 485 of those rare label combinations, right? So basically, I will remove those and then split my test into a 10%. You can make that number what you want, like 20%, 30%, 50%. Split it how you want, right? But basically, if we split that in 10%, then we have a training data set of 51,000 and so much of the sentiment, emotions, and text associated with it. And we have a test set size of 5,724, which is stratified, which is cleaned up, which is reduced. I mean, so that we basically have only the subsets of the unique combinations of our labels, right? So the stratification happens to be done here when I give the stratified on my uh, filtered labels column, which is these, like, I would call it bit arrays, which is not really what it is, but basically that's the way it's gonna be able to stratify. Okay,
It's a
so
vector.
yeah. Okay, so let's make some visualizations about all this, right? In the very beginning, we had this data set with a lot of messages, and this is like the 200,000, so it's all like splattered up. Then we have cleaned up our data set, and now we have like maximum 50,000 messages, and they are still distributed in a very weird way. But the neutral has come down where the neutral was like number one. Here, the neutral has now come down to some more normal. Where are neutral? Did I remove them from here? Yeah, looks like. But anyway, I mean, the data set is now much more reduced in the number. Um, the data set with the top three has been changed. Now we have for each class better distribution, and especially between the train and the test. And so now if I stack distribution, so now we see that for each of our categories, we have a portion which is in the test and a portion with it in the train, right? Now, I think this covers it basically. For the rest, like these are the same but sorted differently. The last step is the most important one, is that I'm gonna save those two now into two different files so I can use and reuse this data set along the road. Did that make sense for everyone? Are there questions? Are there things that people would like, yeah, clarify or have clarified? Was I clear? And again, I don't pretend to know everything, and I'll probably took shortcuts and explained things like short, but
The
I
chat
hope you.
is popping off.
Okay.
Chat's
It seems like
popping off
there's
with
no
fire.
questions, but everyone is excited. Yeah.
They're with you on the same page.
Okay, perfect.
was
Then
gonna, s- I was gonna say I really like the graphs. So great work on the graphs. Visualizations are very
Yeah.
important. So great
I
work.
I think an image speaks more than 1,000 words. So you can have like those counters and whatever, but when you look at the charts here, they speak for themselves. And especially like the very first one, when we look at the distribution here, you see that there is a problem because there is like, and imagine this in a training in a data set in something for the all that white area is wasted area. We will see max sequence length a little bit later, because that's how you basically make a model, and you determine what's the maximum you can train on. So the max sequence length will stop somewhere else. All this is garbaged space, is garbaged memory, because there are no messages in there. There is nothing that will do that. So unless you're working with embeddings and those kind of things that other ways, but all these will basically be white space, and will be not that much used. And if you look at what it is, if it's not white space, it's useless. I mean, at least in my case. So it doesn't help to the quality of the model. And yeah, charts show it all quite easily. The matrices here shows it all. There's also with the zero column, it's just like, yeah, assess, make sure you verify what you're doing in the code, verify that everything is like looks straight, and yeah, it makes of course a lot of sense. Okay,
Yeah, like
so
it was a log normal distribution, and then you like truncated it to like a normal distribution. So very good. Yeah, great work.
Your
thank you, thank you.
cookbook is on point.
Yep. But yeah,
Everything
there,
is
there are a lot of
awesome.
things I explain in my cookbook which are different of these, or again, this is just like a global line to explain the very specific case of this data set, the Go Emotions data set, right? So we've seen and we've done like handling missing values. I mean, there were all the emotions which has nothing been tagged, I've set as neutral. All the ones that had too much, I've set as non-neutral. The remove duplicates, I corrected errors. We ensured a bit more of a balanced feature, but certainly we ensured that there was balancing of the features between train and test, right? Um, okay, so now, the very last part I want to speak about is mitigate biases in such a model, in such a data set, sorry. And they already did a good work on the Google team when they were collecting this, because a lot of the text, which contains eventually names, religions, races, minorities, and so on, were replaced by tokens. I will see if I can get an example of that. Here, the first one. You see, so reminds me of, and then they have replaced the real name by this token of a name, right? Now, let's say you have collected comments about some artist, right? It might be that Beyoncé is more preferred and loved than Taylor Swift is at the moment. If we leave the names into there, we will train on those names. That means that our model will now be influenced by Beyoncé or Taylor Swift's popularity, and not just by the other words in the prompt. I mean, sounds silly, but
This is
it
the
is a
same
way.
data set.
Yes, it's the same dataset. It's
Okay.
the dataset I just opened. I just want to show out that they have removed names and replaced them by this token to make sure that you don't train on special names or biases like races or religions. They also replaced the religion to avoid like cliches being transported and being trained on, because it happened that you have a lot of bad messages about one particular religion or a minority or whatever, and it's gonna train on that word too. So Islam or Christianism or whatever could have better weights or better sentiments than the other one, not because of the words around it, but just because the word appeared in more negative comments and positive comments, right? So you wanna avoid that kind of thing. So that's what I said with the mitigate biases, right? Remove names, personally identifications, whatever that could direct your model to something, and then you have a lot of positive or negative messages. They are not associated anymore to Taylor Swift or to Beyoncé. They are just associated to the word name. So yeah, that's a way to remove the bias. And again, that's something you should like um, think of, right? I don't know if there are issues with the stream, but I don't think. Yeah, looks like
No,
everyone got it right.
looking good now. Doesn't seem like there's issues. You good? Sorry, go.
Okay, so the next step. Now we have that. We have a data set with columns and text and also, yeah, right. But that's not yet something we can do something with, right? That's good for training other models, and that will be part two. The part one now, we will try to continue on generating a fine-tuned data set to fine-tune our model doing this. So I will proceed to a step which is data augmentation. We have this data set, and we will define a couple of tasks that we want our model to do. We want our model to be able to detect emotions in certain text, and we want our model to be able to generate text depending on the emotions we give. So I will be using two prompts at least, or two types of prompts, to make sure that we will have various tasks. There are a lot of tasks possible. I will now just focus on two out of them, right? Um, why data augmentation? If I still always use the same prompt, then I will basically burn into the memory of my LLM like, hey, this is the exact sentence we want in the instructions to obtain this exact same answer. And that's probably not a good thing, right? Um, the user that will be using your LLM might use a synonym, might use another verb, another tense, might use another way of expressing it, might type in typos, and so on and so on. So you want the LLM during its training to generalize, to consider that the instruction is not as much important as the sentence itself, that the task that we are given can be expressed in 5 different manners, but it's still the same task. And so you want to distribute the weights between the prompt itself and the sentence itself. And so that's also, you don't want your model to always answer in the same way. I mean, or you want it, then you can also force that, right? But very often you don't want your model to strictly answer with the same sentence every time, right? So I'm going to be using prompt generation to increase the data diversity, to mitigate the overfit, making sure that it's not learning too much on exactly this text and exactly this prompt, and to ensure that the model is more robust, that it can live with some typos, linguistic styles, and so on and so on. Okay?
I'm not sure if you're able to answer Roland's question in the chat, but I'm not able to answer it.
NLP, what is the library? NLPO? No, I'm just using my own on the augmentation. I will just show you how I generate them myself. There might be libraries and so on. I've tried to keep this like kind of easy, simple, and I will use a couple of preset prompts to do that. Yeah, and I mean, I've generated a couple of prompts using other LLMs and so on. But again, I want to keep this sample like a bit uh, I'm gonna concentrated and easy, right? So I have made this data augmentation part. Let's go back up. So, let me show you what my tasks are about. So I would have a task emotion detection. The emotion detection goes like identify the emotional tone present in the given statement, given the sentence. The sentence expresses the emotions. Another way to say the same thing is classify the emotion present in the following sentence. The given sentence, the following sentence. Identify, classify, emotional tone, emotions expressed. Identify all emotions present in the following sentence. The emotions are. This answer was just emotion. This one was the sentence expresses. This one is the emotions are. Classify the emotions and their intensity in the following sentence. This text exposes as emotions. Detect the emotions in the following text, right? So for the emotion detection, I'm now giving 5 alternates. You could do that with like 10, 20, 100. The more, the better, I would
Did
say.
you
But again,
write
the more,
these
the better.
by hand or did you generate these?
No. I used some LLMs to generate them, and so I have another notebook that will be.
Okay,
I'm not gonna go through this right now here,
sure.
but you will receive that for free in the sentence in the thing. I have so made also a cookbook to just generate those templates, those prompts. Sorry. So you are an expert and so on and so on, and he will generate you different prompts and so on and so on for that. So I'm just trying to keep the first part like kind of short or concise. Um,
Sure thing.
so I went to up these prompts. Another task that we might have is the emotion generation. So what is notable here is that from the same data set, basically I have sentence and emotion being input output, and now I'm gonna have the input and the output be reversed. So create a statement that conveys emotions. The expression is sentence. So you see on how from a basic data set, having just zeros and one in columns, we can turn this to two tasks already, to generate it and to detect, right? And again, I will use different sentences, different formulations to formulate a sentence that conveys, compose a statement that captures, create a phrase that delivers, produces and communicates, and so on, right? And again, answer questions, answer questions. If you want to avoid the model, which is sometimes something I find like annoying when you ask like a 5-3 model or whatever, please respond this and do only answer. And he starts with, yes, sure, here is your answer. Jesus Christ, tried to ask you not to do so. Then just make your data set so that it's like this. And so you make sure that your model is trained to just answer with the three emotions and not make a sentence that is, yes, sure, here is what you asked, right? So it's all about your
So
personal preferences, about how you want to do it.
my
But yeah,
question would be, this is your data set for controlling the input and output.
generation.
So how does this combine with the other Reddit data set?
I will show you. I will show you. So this is just like
Yeah.
a file I've made to define the prompts and to define the tasks.
I
And
assumed like you're going there, but
yeah,
that
yeah,
that's
yeah.
what my question would be now. But yeah, I mean,
Then there are other questions you can ask, like having more of an emotional analysis. You can also have like a computer conversation, and you can ask like, was the person A is getting sentence A and then sentence B, like right? So you can combine those prompts. You can have much more complicated tasks. I will now just focus on the two first ones. But you can do like based on these emotions expressed in the following sentence, recommend a course of action, and then you got a response, which is not exactly in our data set, but you can generate this using another LLM and so on, and you can have much more complicated tasks, like you have summarization, classification, and so on and so on. So I'm gonna focus on the very first two tasks because they are easy. But as you can see, I went wild in this file, and you can go like for 10, 15 different type of
and
tasks, right?
and what you're saying right there is your Keras model is more focused on classification, but just by the way that you've constructed your data set here, once you put it into an LLM, it will
This is
already
just for
have
the LLM.
those, it'll have
Let's
those
keep the
other things.
Keras.
Oh,
Let's keep
this
the
doesn't
Keras out
even
of
get
this.
fed to the
No,
Keras.
no.
Okay.
This is still yet just for the LLM.
So just now I'm gonna generate a dataset which is good for the fine tune by making sure I not only use the samples we have, but I make a diversification of those samples, right? So in this notebook of the data augmentation, I will read the prompt file. And for each of my prompts, I have like these placeholders being set. And the more you go to other, you can have other things like I can have prompts where I have an image description and I ask the user to tell me which emotions this image invokes, right? I have things with a sentence and a second sentence, and I can ask like, please make a harmful response, please make an empathic response, please make a, so I have also like response styles being. I'm just gonna focus right now on what we can do with the data set we've built, which has the emotions and the sentence. And in the first example, we will give sentence in input and get emotions as output. And in the second part, we will have the emotions as input and the sentence as an output, right? So I'm basically now, let's just run them to make sure. But I'm gonna make a labels column which contains the text description of every emotions because it was all just an array of zeros and ones. So now I made one where I got like these text being for each of the records. So now I can also choose by how much I want to augment my my data. Now I have 5 prompts for each. I will only take 3 out of them for each of my messages. So for each row in my data set, I will now put that together with one of my prompts to make one thing. So basically every sentence will appear 3 times with a different prompt each time so that we get that diversification. It once talks about feelings, once about emotions in the text, in the paragraph, in the message, and so on and so on, and that will mix up to create a triple data set. As we do it for every task, this will basically also double the data set. So we will end up with 309,000 messages instead of a bit more than 60,000, right? So run this. I think this was already done. And in the end, you can directly go to Hugging Face because you now have the fine-tune emotions dataset on Hugging Face, which is the one we've just prepared. So that's cleaned up. That's you have the task here. So we have the emotion generation and the emotion detection. You have the input field, the output field, the emotions field itself, the sentence that was used for it, and that's basically it. We now have everything to go on and fine-tune the model. Does that all make sense, guys? Is that all loud and clear? I don't know, Daniel, if you have something to add on this. I know you were like interested by the technique used.
I think that's very good. Like, keep going. Yeah, very good work.
Okay, great. So I pushed the dataset. We got the dataset right now. I think next step will be to actually do the fine tuning, right? So that's the place where we're going to do the fine tune with Unsloth. And thank you to the Unsloth guys for working hard last days to get the Ollama support so I can make it an end-to-end and get back, collect that back uh, to Ollama directly, right? So
Yeah, thank you guys. Like, you guys are putting in a
maybe
lot of hard
Daniel,
work.
I can leave the floor to you for explaining how the notebook works outside of all datasets, and then I can hang back up to how you use with my dataset. But I think if there is something to say about Unsloth and to present Unsloth, then the floor is yours.
Yeah, okay, well, thanks so much, Sebastian. Like, fantastic presentation. Yeah, like, yeah, we spent quite some time trying to make Ollama work. And I think like Ollama is just like extremely fantastic for people to use because it's so simple and easy to use. And so like, we really wanted to make it work for people. And I think we finally got it. I think like lots of people like, when Sebastian was talking about, fine tuning for emotions, and AI, like, sometimes the template can be very hard to do. And so like we try to make it as simple as possible. So wait, should I share my screen? Does that work?
Yeah.
Yeah.
You can.
Or a button? Wait, let me just try. Wait, how do I?
think you have
Oh,
to
isn't it share screen?
request,
Oh wait, is
or
it because you're
yeah.
sharing? Oh, okay. Yes. Okay. Oh wait, did I? Okay. Wait, give me a second. Let me try this.
You're good.
Sure.
Yes. Well, thanks a lot again. Wait. Okay. It's whack.
We're
Can people see
all
the?
we're all experimenting in this event space here. We've never done this event thing.
Yes. Wait. Can you
You
guys see the
are
Ollama plus
appearing.
Unsloth plus Llama?
Yeah, you're sharing your
So it
window.
works.
It's
Okay.
just the
So
window there.
oh wait, is it correct? Is it correct?
Oh no, it's good.
Yes.
You
Okay.
must be on a small thing.
Okay, cool. Yeah, so like I think so. Yeah, so my brother I think put the link to the collab notebook. And so this is just a general Unsloth notebook for fine tuning. So you just have to
Yeah,
install it. This is
sorry to
like just
interrupt.
generally.
Sorry to
Sorry.
interrupt it. We still can't see anything here, Daniel. Can
Oh, I
you
can
guys see
see
a
it.
screen?
I mean, I can
Just
see
to
it.
confirm.
It's like it's good for me. It's like
Yeah, but
you
like,
see a collab.
yeah,
I have also a loading screen, so I can't see
yeah.
it on my
We're
side.
still on the loading screen as well.
Hmm.
Uh,
I
a
can
few
see
of
Maybe
it.
us.
can
Let
you
me
Okay, wait, let me
stop
try
and
again.
restart? Yeah.
Yeah, let me start again. Yeah, okay. Let me try again. I'll try to do entire screen this time. See if this works. Can people see the Discord? That
I
like
can. For me, it's working.
For me
can other
not, but
people see it?
anyway.
Um,
No, I mean for me
Oh,
not, but I can live with that. That's not a problem.
Yeah,
I
we've got.
know it by heart by now.
well, I am
oh,
recording
it's
it,
in
I
the
guess.
chat.
It'll be in the recording.
So it's in the
So,
yeah the collab notebooks in the like the chat. So like when you
Yeah,
open it up,
I know them all,
so like when you
bro.
open it up, it should be so you just when you load like when you can just press run time and press run all to like actually run the notebook. And so like this is just a general notebook that we share to people. You can like we can fine tune Llama 3, Mistral, Phi 3, and any model that you like. You can I think people don't know that Unsloth actually supports any model. So like you can actually type whatever Hugging Face model that you like. You can see like if you go to Ollama's website and find which model you like, you can just type something in here. But it has to be on Hugging Face. So like don't try to like put like GGWF type models and stuff like that. You have to put like Hugging Face type models in this area. But any model should work. And I think so. Sebastian was talking about maximum sequence length. So you can essentially put any single number that you like and this model, so Unsloth will extend it for you to like infinite. So like obviously don't put infinity like some sort of like large number or something. That's probably not a good idea. But if you want to do long context fine tuning, so if you want your model to learn about very long contexts, you can change this number to however you like. But we normally suggest you to like just use 2048 for like general use case. Load in 4-bit is equal to true. This is doing 4-bit quantization. So if you don't do this, your model, when you do fine tuning, your model can use like 16 GB of VRAM, and that's extremely, a lot of VRAM. And if you use load in 4-bit is equal to true, this essentially divides your memory by 4. And so your fine tuning only uses like 8 GB now. This includes the gradients. So always set this to be true. Some people have tried it to set it to false. So this does 16-bit full full quality fine tuning. But this will probably go out of memory. So I do not suggest you to do that. Just generally set this to be false. So this is just setting up the fine tuning process for the model. If you want to inject knowledge into the model, if you want to change the behavior of the model, you can change the rank. So if you want to increase the rank, this essentially allows your model to learn more about your data. So if we set this to be 16 because it's like, a bit more faster and very general use case, but you can like increase this number to like 32, 64, 128, or whatever number that you like. But we normally suggest you to try to use 16. The target modules, you don't need to worry about this. We selected all of the linear layers for it to target, and this will be adding small little modules to each of these layers, and these are the ones that we are doing fine tuning on. So we're not actually trying to fine tune or change the weights of all the entire model. We're just going to be changing the weights for some of those weights. The alpha, we generally suggest you to set it to be equal to the rank. So if the rank is 16, set it to 16. You can also do times 2, but generally it's, we just tell you people to like set it to be equal. And also use gradient checkpointing. This is a methodology which we created, which allows you to reduce memory usage dramatically. And this does not affect the quality of your model. All it does is we offload the gradients to your system RAM and not use the GPU. So this essentially allows you to do very long context fine-tuning, around 4 times longer than Hugging Face and Flash Attention 2. So so if you set this to Unsloth, this will enable that. You can also set this to be true, and this will like use a bit more memory, but it still works. And the trick is, if you set this to Unsloth, you don't actually, the time for fine-tuning will only increase by like, 1 or 2%. So we always suggest people to do this. For data preparation, so we're going to be using the alpaca data set, which is over here. Oh, okay, it's too big. Let me decrease the size.
And
and so
just
essentially
real
the
quick,
alpaca data set has like an
I
yeah.
just want to
So
say a lot of people can't see the screen share for some reason, but you're getting captured by the recording. So just keep trucking along. You're doing real good. Anyone that's missing it right now, you'll just have to rewatch the recording because I don't know what's causing the event to be weird in Discord. Only certain people in the Discord can actually see your screen share right now, but I'm
It's
recording it,
recorded, so
so
don't worry. Yeah. Let's
Oh,
continue.
okay.
Yeah.
Sorry about that, guys. Like, there is like a collab notebook for you to like. So it's in the chat. So if you like follow that along, I'm just doing the collab notebook. So like you can run that and then yeah. Sorry about the yeah. Okay, I'll just go to the collab notebook then. But like essentially, so we're currently at from datasets import load dataset. So like we're currently doing like dataset is equal to load dataset alpaca GPT-4 that area. And you can see that the column names in the dataset are instruction, input, output, and text. So there are actually 4 columns in the dataset. And essentially, this allows you to input any single dataset that you like if it has these types of columns. So right, you need to have an instruction column, you need to have an output column. The input column is, it's optional, but essentially this is the requirements that you need to have before you start a fine tune. So every single fine tuning process requires a dataset with the 2 columns, output and instruction. Yeah. But so the trick that we did with Unsloth is we noticed that people keep having problems with this requirement. So your dataset must have an instruction and output column. But what we did is we created a new function called toShareGPT. And this essentially allows you to merge columns into one instruction. So if your dataset has like 10 columns, we can essentially merge all of the 10 columns into one instruction. And so this essentially is the merged prompt example, which we'll be sharing for people to use. And essentially, if your column is called instruction, you have to bracket it with the brackets, and this is the start of the instruction. And the double brackets allows you to input an optional instruction into this. And so like essentially this optional instruction, if the input is empty, this will not be printed out, right? So this will disappear. But if there was an input, this entire text will change. So this is actually very, very useful for people who have data sets which have multiple columns. And the trick is we require you to have only 2 columns, right? The instruction and output. And all of this does is that it makes your data set merge all of those columns into one column. We also make this new special methodology called conversation extension. And this essentially makes your data set randomly become a conversational style data set. So the biggest issue people had when you make a fine-tuned model is the model it only learns on one prompt example. So for example, if you have like one row of an example, it's not going to be very effective. And what this does is if you set it to 3, we will randomly shuffle your data set to create a conversational data set. So essentially, we'll pick 3 rows from your data set and combine them together into a conversation. And so we found this to be very useful for fine tuning, and it increases the accuracy and also like usefulness for these models.
what basis does it go? It just is completely random for the 3 that it picks?
Yep, that's correct. So like for now, what it does is that we assume your data set is like, randomly distributed. We assume there's like, it's IID. So like we will essentially select 3 random rows from the data set and just concatenate them together. And this will make like a conversation.
Nice. I like
So
it.
you can also you don't need to select 3. You can select like 5 conversations, 10 conversations. This number can be tuned. So whatever that you like, you can put this on. You can change that. We have another function called standardized ShareGPT. So a lot of people use the ShareGPT style dataset for fine tuning. We essentially now allow you to standardize them to make it available for fine tuning via Unsloth. And this allows you to export to Ollama very easily. So, please use this function called standardized ShareGPT. And the most important and the most, sorry.
Yeah, no, I do use all what you've specified for the training of the model, and so they will see it in action kind of soon. Yeah, just go on.
Yeah.
I mean,
Yeah.
Sorry.
So, like, I
Just
think
a
so the
question here.
biggest,
Sorry, Daniel, I'm really sorry to
yeah.
interrupt. Just have a question. Seb, can you see Daniel's shared screen right now? Yes or no?
no, I don't, but
I
that's, I
can.
mean, not a problem.
I don't
It's
know. I
recorded,
don't know
so
why
Yeah,
we'll find it.
yeah,
Borge can
no,
see Daniel's
that's
screen for
fine.
some reason. Borge is the
It's fine.
only person who can see Daniel's screen, but Borge is
Yeah,
recording,
Oh, is
so
it just
yeah.
one person?
yeah, I
Like,
am the only one who can
oh,
see it,
Sorry.
but I am also the person who's recording, so it's okay.
Mm.
It's very stupid, but it's
I was just
it's
gonna share
okay.
screen what you're seeing through my screen for everyone else to see. Basically, portal in through
I don't think
yours.
I
No,
can
so like,
because
it's
I
not.
tried
Okay,
It's not.
and
cool.
it
No,
doesn't
fine.
let you in the event. You can
Sorry,
only have
sorry.
one. You can only have one screen share at
Let's
a
move on.
time.
You want to try reshare?
is it
Or...
like just doing the circle, like the moving, like
You're,
the loading
I
screen?
can see literally everything, but for them it's a loading screen, and so I think you should just finish up because I'm recording it and I haven't missed anything yet. So I still see everything in your collab there and your Hugging Face and yeah, in your Discord I can see you are a helpful assistant on your screen. So I would just keep going from where you left off, and anyone who's missing
Okay.
it right now can watch the recording later to catch it.
Yeah. Oh, we will. Yeah. I will, like. Yeah. Yeah. Luckily, there's a recording, so apologies for like the technical problems. But yeah. Okay. I will just continue, and then I would just take questions afterwards. But so essentially, the biggest innovation that we did is something called customizable chat templates, and we found this to be very helpful for people who want to make Ollama type models, and for any single chat assistant type model. So essentially, what this does is essentially you can make a custom chat template and then we create an Ollama model file automatically from this chat template. But there is a condition, and the condition is you must input 2 examples or 2 repetitions of the chat template. So you have to specify an instruction, a response, and then you have to do it again. And the whole reason for this is that some people have dangling new lines. So whenever someone does a fine tune, sometimes there's like extra new lines, and we found this to be a very pervasive problem for fine tuning. And so by using 2 repetitions of the chat template, this essentially deletes all problems of like new lines. And so the chat template is fully customizable. So you can you can literally edit this. We use the general alpaca standard, like below are some instructions that describe some tasks, write responses that appropriately complete each request. And then the instruction, and then the response. And then remember, you have to do 2 repetitions of the instruction response. Right? This is compulsory. If you don't do that, then it will error out. You must provide 2 repetitions of the chat template. And then you use the function called apply chat template to actually, apply the chat template onto the dataset that you already provided. We also have like other examples of like, the Llama 3 chat template. How do you actually specify this in the new methodology? And other like custom templates that you can use. You can also use a system prompt, which is like an optional prompt that you can provide. And also when you want to train the model, this is just using general Unsloth training. You use TRL's SFT trainer, and we just specify some general, numbers that we always do for Unsloth fine tuning. And then when you do train, you hit train, the training loss definitely decreases. And then when you do inference, we change the code a bit. Because this is now conversational, you must use special methodology to call the model for inference. And the inference is like, for example, we ask the model, continue the Fibonacci sequence. Your input is 1, 1, 2, 3, 5, 8. And if you call this, the model will generate, the next number in the Fibonacci sequence is 13. Some people were complaining that the Hugging Face generation for the model like includes the prompt. And we found that if you type in skip prompt is equal to true, this would delete the prompt and only output the response. And because this is a conversational style model now, you can essentially add, multiple dictionaries into the list. The role is the user, an assistant, and then the user and the assistant. And this essentially mimics ChatGPT, so you can like essentially customize and make an actual assistant out of this. And finally, let's skip all of this and we just go directly to Ollama. So now Unsloth allows you to export the fine-tuned model directly to Ollama. So the first thing that you have to do is you have to install Ollama. So you just follow the Ollama installation instructions on the GitHub. Like you use curl and then get the installation file and just run the install. And then
I
the
got
next thing
that.
that you do is you have yeah.
Yeah, sorry, Daniel. I got that all on my following up. So if I can show
I'll
that
let you
the get back
yes.
onto Ollama, having it work in Ollama, but so
Yes, I'll let you continue sharing that. Yeah, wait, let me stop sharing the screen
I
then. Yeah.
applaud I
Okay, your
applaud you,
screen
Daniel.
probably works.
Thank you for all of your
thank you.
amazing work, and Mike as well. You guys are really creating an amazing tool that is helping a lot of people.
I hope I
Yeah,
will be
thanks so
able to
much for
share my screen back. Yes, screen one. Hopefully
And
that
sorry
works
for
for
that screen
everyone
share
directly.
issue. This should work again, right? Everyone can see Seb.
Can everyone see my screen again?
Okay, you can see Seb, so no problem as normal. It was
Right.
just Daniel, sadly. But we'll check the video later, shot for the recording.
Yeah.
So yeah, that was the notebook we were speaking about, and so to quick recap, we basically gonna load a model. You can have a couple of parameters. I've documented, by the way, a couple of those. I made a contrib to our friends of Home Unsloth about all these parameters. The defaults are fairly enough, and so the template he was talking about is this one in an alpaca style, but that's the alpaca. Sorry, I had the Ollama one. Let's take that one, right? Okay, so yeah, the parameters we just told, loading the dataset. Then you have that to chart to ChatGPT, which will make conversations out of it, and so on and so on. You got templates, repetitions. Here we got the instruction and output. Then the chat templates is what we're gonna use in our Ollama model file to load that in. Then we're gonna use the trainer for a number of epochs or steps, warm-up steps, so on. The defaults are fairly good. If you feel there is something wrong with your training metrics, like not going down or whatever, you can start to play with that. But one thing I wanted to say, the metrics that you're gonna have, like the training loss, are very in line with what we've did in the cleaning up of the dataset. If we have garbage, don't expect these metrics to go down well because you have contradictory samples in the same training data. So at some point, your model will not be able to learn about it. If you say something is green, blue, and red at the same time, how do you want it to basically know that? So you can have your metrics like being stole or even going back up because your model cannot figure out what's in your training data and how good it is. So again, very important to have clean training data and good samples if you expect your training to occur correctly, right? So,
Um,
yep,
there are some Slido questions.
yes,
The first one is uh, floating point 16 versus 4-bit means also lower quality question mark, or it's going to be the same when the floating point 16 model is quantized to 4-bit question mark.
that's more for Daniel, I guess. But so
yeah.
what do you? Yeah.
So I think like in general, if you do float 16, you'll probably get like plus 1 or 2% accuracy. But I think it's not worth it if you want to like increase memory usage by times 4. So yeah, hopefully that kind of yeah. So like generally just use 4-bit. You can essentially even if your accuracy decreases by 1 or 2%, if you, as Sebastian said, if you like change the parameters like learning rate and other parameters, you can essentially recover the accuracy. And sometimes 4-bit can actually have higher accuracy than 16-bit. So just use 4-bit.
We also have another question here. Is ChatML template supported?
Yes, they are, and they are in different manners. There are a lot of templates being supported. There is also a special Unsloth template. If I'm not saying something wrong, Daniel, correct me if I'm wrong, of course.
Yeah, that's
But
correct.
yeah.
That's correct. You're correct. Yeah.
And we have a third question. Sebastian, thank you for your great presentation. Can you please expand on contradictory training data, specifically where scientific findings contradict? It's from
Well,
Marco.
when I was saying about contradictory data, it was like the sample we've seen in our data set where you have like multiple raters giving different emotions and maybe giving different emotions to the same sentence. So you would have a sample in your data set that is like I will refer to the colors, but you say like which color is this apple, and one says it's red, the other one says it's green. If you have that in your data set and you try to train on it, how do you want finally your model to have the good answer? What would be the good answer, green or red, or one of both? So if you have contradictory data into your training set, you cannot expect your training to reliably answer the good answer, right? It will answer one of both randomly because it's in that distribution in your data set, right? Does that make sense?
That makes a little bit more sense. Thank you, Sebastian. So I'm
No problem.
thinking if I have a large training corpus, and let's say that we're looking at data from the mid 90s, Pluto is considered a planet at that point, and then by 2005, Pluto is no longer a planet. Uh, I'm guessing my original way of performing training has just been, or listen, for additional pre-training, has been to train basically chronologically from publication date. That way, new factual findings are redone, and then we can also try and perform standard testing to make sure that it's going with the modern standards. I'm guessing that this is on a different topic than the emotional that you
Yeah,
were
yeah,
referring to.
yeah. I really was just talking about, like I said, redundancy or
Would
fault information.
would
Now,
that be
what
more
you
of
are
like a
talking about
RAG?
is more an evolving information, something that was before and was ground truth by that time, and is now different. And so probably you would add into your training data set something like before that year it was considered a planet, now it's not anymore, and so on and so on. So you would add justifications or details to your training set to do that, to explain that
Okay.
change in the matter of time. I was really more talking about conflicting definements in your data set, and if we didn't clean up like we did with the majority vote and those kind of things, then it would be very difficult for your model to sort it out, right?
Yeah. Okay. Thank you. I understand that better.
So basically, everything that Daniel has explained in this notebook applies, and I basically have taken over everything into one single script that I can start from the command line. But it's the same as the notebook. I just copied over things, right? The other only thing I've did is to put my own data set in there, so you can use it directly on the Colab with my dataset that I've pushed now. So the augmented dataset with 5 times each emotion and so on and so on, and to generate to train and generate finally, and to save it as the emotional llama. So now I have a model here, a DGUF file, which is my emotional llama. I made a model file out of it. It's not that one, but it's this one, right? So where I basically give the file name of the GGUF, and I use a template as it was provided on the notebook, right? So last thing I've done for this was then launching the create command with the name of my model and the link to the file. Whereas we can see then, Ollama has done some creating, transferring the data, and so on and so on. And now when I do Ollama list, I can see that I have my emotional llama model being there, and I can run it. So we can now do emotional llama and start it. Now I got like a couple of things that I've tested out. Like, let's see, what are the emotions in the following tests? What are they? Admiration. That's probably not really a good one. But I did like other examples like with the smiley, and then we are more on joy, and then I did one with the bad smiley, right? That's a couple of simple examples.
Can we take a
Disappointment and
user
sadness.
suggestion? Can we get like a chat suggestion for something to analyze the emotion of?
We can. I mean,
Does someone
I
have a
just
fun
wanted
idea?
to point out that, I mean, these are effectively the ones we have in my dataset and so on. And so it's not words made it out from um, from something else. It is. So I will take like the message of Daniel right now. I was trying. I was trying to. Let me see if I can copy text. Yeah, right. Oh no. I mean, there's. The remote screen and so on. So it looks like he doesn't want to take it over. Copy text. Does that work? Not yet. Okay. So
You want to say what are the emotions, right?
well, yeah, I need to. I mean, I need to at least take something similar to what we've said, like
Yeah.
the emotions, what are the emotions in the following text, and so on and so on. So at least I need a start of a prompt. Otherwise, it would just like respond to a logical conversation. We didn't make our model doing only this, right? We did our model so that it could basically analyze a couple of different ways of expressing it.
Sure, you
So,
could show that as well. I mean,
what was that?
you could show the other generation method where if you remove the
Yeah. Or I can ask like, please generate a sentence that expresses joy and amusement or admiration. That's good. Admiration. And this is also the things like we had, like, hey, here is a sentence that expressing, and so on and so on. You see that even this has been like taken over. So
nice.
the placeholders from our training set. So it's not just made out of nothing. This is really my training data that is reused, right? So yeah, does that make sense, guys? And does that like, yeah?
Absolutely. Yeah, it's freaking. It's nice to see it come together.
So I think this completes like the
Please generate a sentence with the anger that Daniel's screen was not working. That
Yeah.
expresses anger. Daniel's screen.
Sitting here offline just singing Kumbaya, Kumbaya.
well, yeah. I mean, it's a sample, right? We didn't work it out like up to the
But
end,
it
but I think
works. It
it
works.
yeah, and I think it shows like a round trip from going from a data set which contains plenty of a lot of things, and then going up to cleaning it up, making a fine tune, doing some data augmentation to make sure that it's not answering to very specific prompts and so on. There is one thing. You could in your prompt have like trigger keywords, like if you do double exclamation mark emotions double exclamation mark, that is the one you want to use, and only this one to answer about emotion detection and so on. So there are a lot of techniques. I only shown couple of them, and the way to go. I mean, it's a field on its own. It's a science on its own, and again, I don't pretend to know it all. I just like wanted to show how to go from A to Z using Ollama, using a bit of data science, Unsloth, and so on and so on. And I hope this was like already very interesting to you guys.
we have
If there are,
we have
yeah.
another Slido question.
Oh yeah.
Should you fine tune on a base or instruct model?
It depends. And I think for the
Mm.
Ollama support, there is currently like not a limitation, but it is more an instruct related. I think, Daniel, am I correct there?
Well, I guess it comes back to your
Yes, you
question.
can do. Yeah, there's like other different types of notebooks we have. Yeah, we
Yep.
instruct and stuff. Yeah.
There is conversational or non-conversational. It depends all on your use case. Again, if you want to use it in a chat-alike application or if you want to use it in a generation application. But on the notebooks, you will see that there are a lot of chat templates being supported and also the alpaca style for instructions and so on and so on. So you can do both basically, right? Anything else? Any other questions? Anything before we move on to the next part, which might be like maybe a little bit more hardcore, or I would say that that's gonna be much more. It's another model. It's not an LLM itself, and we're gonna use some keras and so on to create really an emotion classifier. Because in our chart of like going on to complexity and stuff, in the very last one, you got like reinforcement learning, and one of the parts is human feedback. And so that's something that is like costly, human feedback, because you need to pay humans to do it.
Can I?
And
Oh, sorry.
so the thing we would now do is, can we use emotions detected in user messages to classify whether our bot is doing well or not? If it's a customer support bot and you analyze the emotions of the answer of the customer, well, you can basically use that as a reward function or as a classification to determine whenever the bot was doing well or not. And you can give it a metric to optimize. Of course, the bot should prefer and optimize for customer satisfaction instead of customer sadness or annoyance. If you detect at some point that a customer was annoyed and unsatisfied and so on, then probably this conversation needs some analysis by an NLP analyst or by a human to see what happened and so on and so on. So the next stage will be, how can you make a model that would be just a classifier model and that can be used as a metric in our system. Remember, in the very beginning, we said that you need some metrics so that you can do an iterative process on these and measure how you get better or better at some things, right? So the next stage will be about this, and one of the things I've often said is that, yeah, don't use a bazooka to shoot a fly. And if you're basically using an LLM to do some classification, it is maybe not a bazooka, but it's certainly a machine gun to shoot a fly, right? So you're gonna have that 4 GB, 5 GB model that needs to be loaded to do some things, and it will basically answer you with words, but you don't need words. You need just basically numbers. You need to know if it was this emotion or that emotion, and you probably want to sum them up over a lot of comments to analyze the direction that a conversation comes. But it comes much more to math than it comes to basically having answers with sentences. So the next stage we will do is now create a Keras classification model, and I will go much deeper on metrics within the training and the way you can do training and so on and so on. But yeah, for me, using an LLM to do just classification is basically using a bazooka to shoot a fly, right? I've made an article on LinkedIn about what is good enough in AI, right? And often I'm referring to that. What is good enough? What kind of model do you need to comply your task without overdoing it, without wasting too much resources to basically complete a simple task, right?
Hey Seb.
Yes.
So you've got your fine-tuned llama, emotional llama there in your Hugging
Yeah.
Face. Um, I just sent. Do you think you could just compare the size of, like, real quick, the size of that llama model to like your Keras as like a
Yeah,
visual?
we will come to the, we will
Okay,
come
okay.
to, I mean, how big the classifier would be. But the classifier is about a couple of megabytes, and this one is probably not up to date. I'm basically making a new one in the following elements, in the following notebook. So that will be again part of the notebook. So to get back to the basics of things, what does an LLM do as the first step? As the first step, an LLM is tokenizing. And again, that's a very important, often oversown question. I've put a video here from Andres Patrick, which is presenting the problems with tokenizers and I mean not the problems but explaining things about tokenizer. And when we think about natural language processing and about the way humans express emotions in their voice, that will be tone and pitch, that will be certain words used certainly, but beside that there is also just tone and pitch, which is something that you cannot find back in messages. Well, yes, you find it back. You find it back by casing. You find it back by punctuation. Ellipsis would be a doubt. Some smileys are expressing a joy or annoyance, like we've seen with the sample I've just did on Ollama. So your tokenizer is of a critical importance in there. So handling smileys and punctuations, like for example, these two sentences, if I just use the default tokenizer, then, and I hope this will just like work out of the blue, I think so. Give it a time to load. So, all right, so I've taken those two simple sentences with the simple tokenizer without any like looking to it, right? So I say that I will train a new tokenizer, maximum dictionary of 250, which is way too much depending on what I have here. Whatever is out of vocabulary will be an unknown. I train it on the sentences I have, and now I will tokenize. And basically I have sentence 0, sentence 1 will be tokenized. And then my question is, are these sentences equal? Well, as you can see, for the simple tokenizer, these sentences are equal, which is definitely not the case, right? But from a simple point of view of a tokenizer, even if we don't give them the sentences here, we make a large enough vocabulary, it doesn't mean it has captured everything. In fact, the smileys were just fallen out of it. So, as important as the data science, sometimes looking back to your tokens, how things are tokenized, is even more crucial than the rest, right? So, yeah, well, what is the problem? Well, the smileys were not taken into account. So let's do another try. Let's now add to our tokenizer directly these ones as being special tokens, as being additional tokens. So now we have every word of the sentence plus all of our smileys being defined. Now it should be right, okay? So let's run this over again. And without surprise, they are again the same. And if you look at the two sentences, they are just tokenized exactly the same way. So what happened? Well, basically, the tokenizer we are using strips out everything which is punctuation because they consider that as word splitters. So they will basically remove all this just out of the blue. So another way to do is to start to replace all our tokens by a special token that we will define ourselves using regular expressions and so on and so on. I will add that to the vocabulary, etc., etc. But at the end now, you can see that my sentence was, oh, what a day, special token 0, oh, what a day, special token 4, and that now we basically have two sentences which have different tokens. We have now an extra token being defined, which is our smiley, and either it's positive or negative, right? But now the two sentences are not equal anymore, which starts to make much more sense. So one that we will use now, we will use a BERT model, right? And important there here, most often you will see something like uncased. But again, do I want to lose casing? No, I don't want to lose casing because that's the pitch and tone of text messages. That's the way you express things when you like use multiple and capitalized letters. That means you're screaming. You're doing. I mean, you try to make your intent very clear. So we will use a model to tokenize, And the two sentences are not the same anymore. And if we take a look, what we will see is that there is a begin of sentence token and an end of sentence token being added to it. All the other tokens are the same, but for our smileys, we now have these extra tokens. And these extra tokens is the ones I've added to my vocabulary at the end, right? So, yeah, that was a short thing, but about tokenizer, I think it's as important as having your data science to know how your text that you're giving into your model will be tokenized and transformed to a chain of numbers. Because if you lose too much information, in a lot of cases that will not be a problem. But in the case of sentiment analysis, losing caps, losing what would be considered as punctuations, but are smileys or ellipses, basically takes out a lot of the emotional sense of your sentences. Okay. So let's go on and move to an emotional classifier. We have made our two datasets and we've saved them, so I can now easily load those. And just as a recap, these are all emotions we have into the dataset, right? I make a couple of sentences, which allows me, yeah, that's the video. No, there is this one, but there's another one explaining expressly the tokenizers. And again, the links are all in my notes, so you guys will have them at the end. Not a problem. But it's one of his first things he explains is that if there is a problem on LLMs, very often it drills down to a tokenizer problem, to a tokens problem. So yeah, that it's fairly important to get the tokenization right or to have an insight on the tokenization before you start to look for your problems anywhere else. So a little bit of those charts again because I like it. Distribution between the length in our test and the training data sets. And so we determine that the max sequence length can be 200. In my case here, it's not an LLM I'm training. I'm training a classifier model, so I don't need my model to accept 2,000 characters long. I only want my model to accept sentences or short sentences, which can be classified as being 1, 2, 3 maximum emotions at a time. So to make my model referably interesting in size and so on, I will limit my sequence length to 200. So same as before, we removed the rows that do not interest us. Forgot that one. Right, okay. So the distribution is good. I'm very interested in adding the smileys, but I'm so interested in everything which is emojis, either the Unicode representation or their textual representation for thumbs up and thumbs down and so on and so on. So I'm going to put that into the vocabulary of my tokenizer to make sure that we have unique and distinct tokens all assigned to these things and that this will not be like cut in pieces of different tokens. I want a single number for these so that they in the future can be referred to and have their own weights, etc., etc. So let's now move on to, again, making sure that we tokenize everything. So what this part will do is it will make sequences that are padded to a certain length. So it's difficult to work with different. It will last longer, I think. I don't think that the stream will end. The event was like foreseen for a certain time, but I don't think the stream will basically end at the end of the event. So the train sequences will be padded to their max length. So we will have each of our samples now being set into a vector of 200 numbers, right? So this now, let's move on to this part. That's still working on. I mean, I just show here, so the sequences, which are the input IDs, which will be interesting in this case. But as you see, they are all 200 tokens long. And then I have my labels, which are these, which is the emotions columns all put into one array vector, right? That one is for another kind of sample that I was creating, right? So now let's put that in an X train, Y train, X test, and Y test. So just checking if the types are good, and that sounds good to me. Yep. Gonna skip this one. Number of classes, and then we will start to have some parameters like my networks, and I have done a couple of different networks and try with different types of networks. But basically, they will mostly work with an embedding model, so with embedding size. And now these parameters become important because the sequence length, the embeddings dimensions, the vocabulary size are all influencing the final model size you will have basically. So I will take the transformer example in this case. We're gonna build a transformer model. So basically a model like um, the, the the models used by LLMs, right? We're gonna put a multi-headed attention. We're gonna have an embeddings layer at the very beginning here. And I'm gonna basically make two layers of attention mechanisms on top of that. Having some dropouts to make sure we generalize that we don't learn every single bit, but every dropout layer will basically throw out information before it reaches the next layer so that we will train for longer, but we will make sure that the model generalizes and do not overfits too fast, right? Then the very last of my layers is an interconnected dense layer that will then finally connect to my last layer. And my last layer will be a sigmoid because I want to get back probabilities of each class and not a special assignment to one of each class. There are a lot of, I mean, on my cookbook is a huge collection of all the activation functions and the cases in which you would use one or the other. In this case, at the end of the model, I want to get a probability per class so that I can take the top 3 or top k of the emotions detected based on that probability. So I want a sigmoid as the very last element of my model.
And just to
So
summarize there, the sigmoid is a waveform distribution that
yes,
you're utilizing. For anyone that doesn't understand what a sigmoid is, it's just like it's like a math function. Sigmoid functions are actually a distribution. Uh,
so yeah, these are all the activation functions. And so the question is on your last layer, you will have a number that goes within a certain range. And then the question is, how do you want it to handle, right? So in a sigmoid, you will have the probability being returned. When you get these, everything which is negative will fall out and being zero, and everything which is positive will go in certain slope or shape to the 1 or to the 10 value. So these functions will return different results basically based on your outputs, right? So we will now create that model here, and we see that we have a different sizes of parameters. But what's interesting is to see that we end up with a model which is 300 megabytes big. And that's probably way too huge. And I will explain with Keras Tuner how you can like find the best combination of parameters. I just chosen one here and gone for one, right? Um, what is important here is the very last step where at the end now here I can use my model and start to predict, and now we see that we have probabilities. This model is not trained, so all our probabilities are basically around the 50%, right, everywhere. The Keras tuner is a hyperparameter optimization. Yeah, you're right. You're right. So I can show how that works if you want. So the hypertune in the transformers model. So I've explained here that I had my transformer model and that I had a couple of parameters like the head size, the number of heads, the fast forward dimensions, the dropouts, basically the input length, but that would be more like a fixed one. The dropout layer we apply on each layer, the last dense layer, and so on. So these are what is called hyperparameters. It's different ways to set up your model. So if you want to find out the best way that your model will act, you basically create a hypertuning, right? And so in that case, you have what's called a hypermodel, and it will be categorized by this. I mean, it will be instantiated by this function that gets a class which is called HP for the hyperparameters. Once you have that, you can say, instead of the fixed values you encode, as I did earlier, I can now say that I have a head size which is HP choice, the value, the name of the parameter, and then I can say, well, I want this search space, so I want to evaluate what the training will happen between 128 to 56 or 512. This one is like fixed values I gave, but you can also give it a range, like a float or an int can be in a range, in a min value, max value, and then give it a step. So you can give a lot of, there are really a lot of different customizations you can do on this. You can do, like, here is a logarithmic sampling of the learning rate that you can apply. You can use just choices, or you can make a range that will evolve by 32 or 16 each time, and so on and so on. So this is all called then your search space. So all your values, all your ranges, and so on is the total search space. And for then exploring that, you have multiple manners to do that. I use Hyperband because that's like kind of an efficient one where he will do a couple of epochs with certain settings and then evaluate what was the most promising, and then go on the next iteration with those as first ones and continue and continue and continue. But it doesn't mean that he will do the entire search space. So instead of the hyperband, you also have, and I guess, yeah, you also have a grid search, you have a Bayesian one. So there are a couple of other methodologies to explore your search space. Once you run this, it will basically make you a directory and test every of your models, save the models, and get you at the very end, like these are the best configurations in order. And so you can then decide which one of the parameters are the best for your own model, right? That makes sense? Has anyone questions about this? Yeah, grid search will basically evaluate each and every possibility in the list. That's why I said, like, a hyperband for me was like a good sample. It's not that critical in my case, so I mean, I don't need to search the entire search space. I'm very happy with just evaluating like a couple of examples each time and go. It can take a long time. It can take a long time, and I mean, it will evaluate. So it depends on what ranges you set. If I say that, like this one, the min value and the max value, but I give it a step of like 0.01, then I mean I have like hundreds of evaluation before it reaches the 0.5 and it has done the entire search space. If I would have like 10 values or 12 values in there, that makes your search space bigger, because now it's actually 3 possibilities multiplied by 3 possibilities multiplied by 3 possibilities and so on. So that's it's a factorial that you will have depending on the search space you are defining. So it can take a lot of time, certainly in a grid search where you need to evaluate everything. In an hyperband, it will still like try to do this in a certain number of epochs, and to keep your total search time kind of limited, right? That makes sense?
Yeah, well, still here with you.
Okay, then we've seen that there was an unbalancing in our data set, right? That we had classes that were much more represented than others. So I will basically make a dictionary with the class weight, and then we obtain like a dictionary that says that the class 0 is much less represented than the class 1, which is, and so on and so on. And this weight will help us in the training later on to have our um, accuracy being better calculated. Accuracy is not like a good metric in this case, And as you can see, it like always like slightly remains around the same number, and you can have very bad results using just accuracy in that case, because we have a vector of 28 labels, of which 3 can be assigned. So I would say that making all of them 0 is probably a much better accuracy than trying to put a 1 somewhere. So you can basically drill down your model to put zeros everywhere over the place, because that's much better. There are much better, there are much more negative values than there are positive values. So having an accuracy there is not a good measure. In the other sense, I will be using other metrics, and I'm probably gonna have that lower on, I hope. No, we'll have to run them again. Did I save those or not? Let me make this quickly. I need to train those to create a model again. Sorry for that. Okay. And I should have run them all from the beginning. Where is that function? Here it is. Right. And then that's okay. Dictionary is okay. Would you like to? No, he's gonna complain. Oh yeah. Okay. My bad. I need to be in my WSL because of strange TensorFlow stuff.
You're all good.
My installation is not that good, so I probably don't want to do this, because I think I've actually tuned this in this one. Yeah, here we got it with the metrics, correct. So okay, excuse me guys. So here we can see the different metrics I've been using. And so one that is important here is the false positive. So number of times my model has basically put into one category which was not the good one, the false negative. So how many times did he miss? Sorry, did he said that it was not part of a, but it actually was? And then the true positives and the true negatives. But as you can see, the true negatives are fairly unbalanced with the rest. So choosing your metric for this, and I see that there are a couple of things going out in the chat, and of course this is very important to choose the correct metric. And sometimes you will not see really the accuracy or whatever moving, but you will still be able to follow up with the false positive, false negatives, and so on, that your model is doing good. So the one that will be interesting here is the, what is it, average under curve, because we have unbalanced metrics. So the AOC and rock, these will be the most relevant to this sample. because we have the unbalanced and we will have thresholds by each category, and so on and so on. So I've made this training and I will put that all online and you guys have to check it out. I've put most of the metrics in there just as a sample so that you could like following up and searching up the things. Yeah, I will send us the links and push that notebook. But I wanted to add all the metrics possible or all the relevant metrics in so that you can follow up and find it and see what's happening and yeah, follow up the metrics, I would say. So at the end, this will create a classifier model. One thing I wanted to show yet here is this chart. This chart is not good. These charts indicate that the validation loss is basically going up instead of going down. So our loss is still going down, but the validation loss is going up. So this means that basically our model is not generalizing. It's learning from the samples in the training set, but it is not applying the same, or it has difficulties of applying the same classification to the validation data set. So indeed, yeah, that the model is overfitting to our training data, that it cannot generalize the data to the validation. Otherwise, both curves should go down, and that's generally a good sign is when you see that both curves are going down. The moment you see that your validation loss going up while your loss still going down, then your model is overfitting. On the other side, if you don't see none of them going down, then your model is probably underfitting and you don't have enough complexity, enough neurons into your model to learn about your data, and so that the training loss will not go down, it might even just go up. Okay, I think that resumes it all. I think we've also passed largely the 2 hours mark, so if there are any questions, if anyone has something, then I would say throw it in the group. I hope it was interesting for everyone, that everyone followed up. Yeah.
Absolute fire and pure educational content. Like legit, and thank you to everyone and for just thank you.
I would say anyway, we will just stop the recording to make sure that we have still like uploadable content to YouTube and so on and so on. So you guys, there will be a follow-up. We'll push the links and the notebooks up to there. I propose we end up the event, and I'll be around in the chat, in the regular voice chat, to have another discussion. Like now, you're mostly all muted and so on and so on. So I will be glad to take that on into the regular channel. Thanks again to the teams of Ollama for leaving me the space for explaining all that. For the Unsloth guys for their work and so on and so on. Yeah, basically, I think I'm done. G Morgan, if you want to add something,
Thanks
a
everyone.
conclusion words, whatever, or yeah, Daniel.
I was gonna say like great work, Sebastian, and thanks to the Ollama team as well. Like much appreciated for hosting us. And I really love the guide and everything that you do, Sebastian. So like great work on that, and again like nice visuals as well. So like great work on that.
Yeah. Okay, well, thank you everyone for attending. As said, I will be in the regular voice chat. See you there, guys. I'll take a short break, take a coffee, and then I'll be happy to join you guys in the voice chat to talk about the following apps and so on and so on.
Sounds good, guys. Thank you again for immense knowledge and just awesomeness. Thank you.
Thank you guys, and see you there then.